issued from Costa Rica. So Sea Shepherd is going to be back, not Paul, but Tamara Aronovich, communication director, tell you what they've been doing since Paul got arrested and released back then, and a number of other great presentations, some archaeology, 1600s, 17th century archaeology around the bay. January, we're going to talk about nuisance and the lawsuit against Central Maine Power, restoring the Lower Androscoggin River, and Mark Beckoff in March, someone I've been trying for probably about 4 years to come and present for us. It's a very, very well-known animal sort of behavioral ecologist, and has dealt a lot and published a lot on the field of animal emotions over the years. And he's buddies with Jane Goodall and all those folks, and he'll be coming in here from Colorado to do this via Zoom. And Shad, and then we're going to be doing a video production of the live show that we did today, and we'll do tomorrow, to be or not to be. So I want to thank Roger for being here tonight. It's a lot of work to put this together, but Roger's been working on these issues for a long time. Steve Kasperzak, who's published Blue Deserts and Arctic Blue Deserts, which really attempt to kind of, they reintroduce and they describe a lot of what we'll hear tonight, and help to reintroduce the works of Hans Noy and Michael Rosengert. And Steve's been kind enough to let Friends of Mirror Bay and a number of other groups sell his book. So if you want to buy one of his books, you can do it on our website or some other ones. And Roger has a slide at the end, show you some of those links, and we'll make a little bit of money doing that. I want to thank Martha Spees, our Zoom tech person here. And if he gets in the mood, her husband Arthur, to helping field questions at the end. And our 2 web volunteers, Martin McDonough, who will make sure this stuff gets up in the general website, and Stan Moody, who puts a lot of the all the technical stuff in our library. And I was going to make a slide, but I didn't. But I think there's a link at the end. We have a section on our website in the miscellaneous section of the library about unnatural river flows, and that is growing all the time. So it's a good resource. And lastly, I'll thank Kieran Yandamuri, who is out in Manitoba now, but who was an intern for Friends of Sebago Lake and F1B a couple of summers ago through the Quebec Labrador Foundation, who I also thank. And Kieran really kind of got started on this project, and what's on the websites is totally thanks to Kieran, and he's off at grad school, and I think was going to try and join us tonight. I don't have a list in front of me of who's here, but if you are here, thanks, Kieran, and welcome. So with that, let me introduce our speaker, and then I can hand the screen over to him. So Roger Wheeler retired in 2017 after a lifetime working in public education, teaching. And his interests in the environment started as a young whippersnapper. Oh, someone just took Roger, you took the screen back from the calendar.
Sorry.
Okay, all right. Well, there he is.
Yeah.
You can introduce yourself now.
Okay.
But anyway, so yeah, but Roger's dad was a geologist, and they spent a lot of time prowling around the shores of Lake Sebago. And in the 80s, SD Warren Paper Company started to manage the Eel Weir Dam, which is the lake's outlet dam, and manage it so that pretty much natural flow management stopped on Sebago. And the lake pretty much stagnated at a high water level generally. And so the normally exposed shoreline was gone, and that steady state water level really prompted a lot of erosion on the shore, and it also degraded the water quality because you weren't getting these natural seasonal fluctuations. And that really got Roger's interest peaked, and a lot of the residents as well, and they took action, and some of those were legal actions. And so that sort of triggered off, like, 30 years plus of learning for Roger about lake and river and coastal environments and the politics of water control and regulation. And Roger helped Friends of Sebago participate in some regulatory actions that advocated for restoration of natural flows or historic flows and levels. And then at some point succeeded Steve Kasperzak, who may be on the call as well, and who I mentioned, wrote these two great books, as president of Friends of Sebago Lake, also called Fossil. And their research, Fossil's research, really formed an important foundation of a court case that went to the U.S. Supreme Court, S.D. Warren v. Maine BEP. And it was Fossil's work on the historic presence of anadromous or migratory fish that was so important, and that basically made that case a precedent setting, in that it named basically hydro dams as, it made them subject to the Clean Water Act, and it made it such that anadromous fish, natural migratory fish, ultimately have to be above these dams. So typically that's done through a biological trigger process where you start at the lowest dam. And, yeah, and I'm gonna finish up here and let Roger carry on. But I thank you all again for coming, and hope you can join us at our other events as well. So Roger, you've got the screen now. You snatched it away, and you can do your share screen. There you go.
See it. Okay. Thank you. It's an honor to be here. I could do 10 presentations on Sebago Lake and the Presumpscot River, so I won't even really better stay away from that tonight. But this presentation wants to promote a discussion of the impacts of Arctic megadams. And it's also a tribute to the late Hans Noy and those who really risked their lives and careers and sacrifice to inform and to warn us about how Arctic megadams are driving climate change and devastating marine ecosystems. This is a dam in Russia. I'll just call it the Cyano. In the questions, don't ask me to pronounce these dams, but I just want you to notice the penstock tubes on the face of the dam. There's about 10 of them. Let's see. This thing didn't move. Okay. Let's see. We had that same problem here. Oh, there it did. I just hit. Okay. I think I got that solved. All right.
Well, now we're back to seeing you, Roger.
Okay. You can't see what I got on the screen?
Nope.
You have to reshare it.
Reshare. Okay. How do I? Oh Lord. Let me just go through all of them. We had this down. Okay. I want to reshare. Hit the navigator.
Green should be a green square. It says share screen.
Yeah, I don't have that. Okay, wait a minute. Okay, I got to go here. Share screen. Go to this again. Share, new share. Okay. You see it yet? No.
We got the last slide now.
Okay. Let me go to, sorry. New share. So go to new share. Nope. Okay, let me go to navigator. Okay, I'm going back up.
There you go.
Can you see that?
Yep.
Okay, I'm just going to keep my slides on the side. I just feel better. Okay, is a tribute to him and how these dams are driving climate change. This dam, notice the penstock tubes. Each penstock tube, 636 feet high, has the capacity to deliver enough water to produce about the same megawatts as all the hydro dams in Maine combined. Therefore, about each mega dam in Russia and Canada can produce about 7 to 10 times the megawatts as all the dams in Maine. That's a big dam. So what's been going on with mega dam building? Well, in this chart from Arctic Blue Deserts, you can see that in 3 decades, really, there was a boom of building, 70s, 80s, and 90s. And this is kind of when things started to happen, you know, in the environment in the Arctic. It was noticed. Of course, you know, fossil fuels is blamed. We're not saying that fossil fuels isn't doing it. It's just there's, you know, is there synergistic effect? Are they amplifying each other? That's for the discussion. This cover of this study, thanks to our intern Karen, you mentioned, was recovered. It's a study on the mixing and circulation in the Gulf of St. Lawrence estuary up to 1964. It's dated 1970. It's an abbreviated version of the unpublished 1964 study, and it wasn't allowed to be released until the Manic Dam was completed, a la 1970. Because of this, the data that NOI found about circulation, how important freshwater flows were to circulation, and realizing what would happen, what already the dams that had been built in the further up in the St. Lawrence estuary had done to the climate, et cetera. He kind of had a Houston, we have a problem moment. He had some early recognition of hydropower impacts and its connections. Noy could see the big picture, which a lot of scientists, you know, have, I believe, don't do this. He was an amazing oceanographer. He could see the Arctic sea ice disappearance, the weakening of global ocean currents, Greenland glacial melting and sea level rise, warming coastal seas, and increasing intensity of weather events. About Hans Noy, he was German born and trained as an engineer and oceanographer. He immigrated to Canada with his wife after World War II. He worked for the Natural Resource Council of Canada for 10 years, starting in 1955, then the Bedford Institute of Oceanography for 20 years until 1984. He published 3 pioneering papers that spoke to his knowledge of large dam and flow regulation impacts. They were runoff regulation for hydropower and its effect on the ocean environment. That was 1976. And the man-made storage of water resources, a liability to the ocean environments, part 1 and 2. He was also, his warnings were cited in books like Silence Rivers and the Ecology and Politics of Large Dams. Thanks to Arctic Blue Deserts, we're grateful that we have, it's like an encyclopedia of information for about on the impacts of these dams. Arctic Blue Deserts is a tribute to the late Hans Noy, and Steve Kasperzak, the author, has reinforced the warnings of Noy and provided new information that corroborates his hypothesis and predictions. This book allows us to understand the complexities and oceanographic principles and why Noy became so adamant in his warnings about the rise of the megadam age. Now, this study took place, of course, in the Gulf of St. Lawrence. It was a big study, used some good-sized ships, a lot of, you know, buoys, underwater buoys to do measuring. It was a lot of money. Shows the Manic 5 reservoir, the arrow to it up there. There's an old meteor crater that is filled. You see where the Manicouagan River estuary enters and where Point de Monts is, where he did a lot of his data collecting. the Daniel Johnson Dam, Manic 5, is the biggest dam, was one of the biggest in the world. And then you have the Manicougan in the lower photo, in its natural state, but no more. It's totally dammed. Before the Manicougan dams, in a few days, water could flow from the mountains to the Gulf of St. Lawrence. Now, thanks to dams, the water takes 8 years to fully circulate down the same distance. The thermal regime and chemistry of the fresh water entering the Gulf of St. Lawrence are greatly altered by this stagnation in the mega dam reservoirs. Now, this is a cross section Noy did in a study, and it's been enhanced by ABD, Arctic Blue Deserts. The river's totally dammed, but you look at the size and the amount of water in it. Manic 5 reservoir has equivalent to 27 Moosehead lakes, and the live storage flow of about 34 cubic kilometers are shifted from spring to winter from Manic 5. That is flow regulation. Now, another sketch by Noy that's been enhanced. It's probably one of the more important ones to understand. The fresh water of the rivers of the entering in the Gulf of St. Lawrence, including what would have been the Manicougan, flows on the south side of the St. Lawrence, the estuary and Gulf. The fresh water is lighter, so it rides on top, but there's through various scientific laws and principles, it causes salt water from the Atlantic Ocean to flow inward up the estuary. I call this the Noy effect. Noy measured that at Point de Mont, there was a 1:15 ratio of fresh water going out to salt water coming in. This is very important to sea life and just circulation and oxygenation. Now, so you get an idea of size of flow. Here's a photo of Niagara Falls. We all know about Niagara Falls. The average annual flow, 85,000 cubic feet per second. Now, for size, the Kennebec River is about 9,100 cubic feet per second discharge into Merry Meeting Bay. So Niagara, that's a good amount of water. We'll call it a big faucet, big tap, water tap. Now, this is a diagram from Noy's 1976 paper, and he shows a graph, a chart of the natural spring pulse that used to occur in the Manicougan River. This spring freshet runoff was huge. If you look at that, remember that picture of the Manicougan 1919 I showed, you can see how the bare rock, I mean, the whole river basin is, most of it, what you see is bare rock. Well, that's full during the spring freshet. Manicougan's considered a small river in Canada. Now, you'll see the dark line now down here is the new regulated flow. Notice in this river, it's actually higher in winter than in the times it would normally be a great spring runoff because of the storage at Manic 5. So thanks to in Arctic Blue Deserts, we could have 1.5 times the flow of Niagara Falls per second per day during the peak of the spring freshet is stopped and stored in the Manicougan reservoirs. So that's what it takes to wipe out the natural hydrologic cycle of this river. Okay. you can ask questions again about this. It took me a long time to get some of this stuff. Here's a larger map of the Gulf of St. Lawrence and the Atlantic Ocean. You see the Gulf of Maine, the Grand Banks. The blue water, the blue arrows, of course, the water, the blue arrows is the fresh water going out. Now, it didn't go straight out. It curls down towards the Gulf of Maine. It goes out the Grand Banks. You have the purple arrows are really, you have fresh water, low salinity water coming down from Hudson Bay and in the Labrador Current. So there's a lot of circulation, but it's been greatly reduced. The rivers in Hudson Bay are regulated. The flow to our discussion is the flow to the Gulf of Maine weaker. We know that all the rivers in Maine are highly regulated, so we really don't. There isn't really much on that as to how that's been impacted. Although we begged FERC to study it, but they wouldn't. Said we were the only ones asking, so they wouldn't do it. But this NOI effect is gone because the 1:15 volume ratio was in 1964, and as you remember from that chart, so many more dams have been built in the St. Lawrence region, so that ratio is much reduced, and we would expect that you get anoxia problems like might get in the Gulf, deep down in the Gulf of St. Lawrence. This happens in other places in the world, that smaller areas especially become anoxic. Smaller seas and big estuaries or gulfs become anoxic. So okay, let's switch to Russia. Over to Russia. There's a lot of big dams in Russia. There's got the Angara, which is part of the Yenisei, the Ob, big dams there, a lot of other dams, and the Koma River, way in the west, is another big dam. These rivers barely flowed in the winter. They're iced up. Now they have fresh water, unfrozen water flows. You have evaporation, heat pollution of the atmosphere and the land, all kinds of impacts. And I was just going to say again, each of these Russian dams produce about 7 to 10 times the megawatts of all the hydro dams in Maine. Here's a space aerial of the Yenisei River and Ob River estuaries. Now, all these dams would do the same thing with the NOI effect ratio. They would reduce it. But one of the things that happens now, you have this higher winter flow, the NOI effect goes into place here because that flow still drives warm ocean water up into the estuary, and that reduces the sea ice formation and melts it from the bottom. At least this needs to be discussed. Now, the estimated pulse energy and volume of 26 Niagara Falls flowing for each second of every day for the month of June never reaches the Kara Sea in the spring, as it once did through geologic Arctic Ocean history. I'll say more recent eras, but because the Arctic didn't exist really in that form till then. This was the ice factory of the Arctic, that and the Laptev Sea next door. So you're messing with this a lot of sea ice, let me put it that way. Now, has it ever been noticed? Well, just checking around newspapers.com, places like that, found this article and others, especially back in the 70s and early 80s, talking about that. After that, the media went radio silent on this stuff. Huge man-made lakes warming up Siberia. Well, let's go to some of the excerpts. We used to have winter temperatures as low as minus 67 degrees around here. Now it's a rare day on which the thermometer drops to 40 below zero. An official of a Siberian city. I talked with one reporter who actually did one of the stories, and he said we never used names of officials or scientists because we didn't want them to go to a gulag. So that was kind of how they operated out the journalists. In effect, what the Russians have done in their drive to industrialize Siberia and exploit its enormous wealth of raw materials is to create inland oceans which account for more humidity, more rain, less seasonal fluctuation in temperatures, and more frequent change in the weather. Now, keep in mind, this is the region where the Siberian high is formed in the fall and the winter, and that drives has a lot to do with our North American climate. So for discussion, what's it doing to the Siberian high when you have all this going on? Whatever their feelings about it, however, and regardless of the potential ecological impact, Siberians are going to have to accustom themselves to Siberia getting warmer and warmer. Yeah, more dams are being built. And a party official for the Irkutsk Oblast, a region of about 300 square miles, bigger than Texas, recently estimated that average winter temperatures in the province are now from 6 to 10 degrees higher than they were before completion of the dam. And the vast 365-mile long, 1.4 million acre lake that is formed behind it. I think you can believe, I don't know if they exaggerate, but it certainly is corroborated by other articles. Let's switch to albedo. We need to understand albedo. It's a reflectivity of sunlight. You have new snow reflects about 90% of the sun's energy back into space. You lose that sea ice. You have open water. You only reflect 7%, and that heat is absorbed by the Earth, essentially. So that sea ice is pretty important for keeping the planet cool. Okay. Now there's this Russian geographer, one of the better known Russians, Peter Borisov. He had planned to change the climate of Siberia. It meant changing, building dams, and really a sort of diverting the Bering Strait waters. And he wrote in his book, the ocean is, of all the natural surfaces of the earth, the best absorber of solar radiation. But the same surface in another state, snow and ice, is the best reflector. Although the temperature range on the surface of the ocean and the ground layer of the atmosphere is small, the water changes its state quite often and fast within this small range. This changeability sharply affects the climate. So true. Lastly, the north of the Atlantic basin may be compared to a bathtub in which cold water is poured from two taps, the Labrador and East Greenland currents, and then warm water, the Gulf Stream, through another. By regulating the taps, we can change the thermal balance of the Atlantic and with it the climate of the surrounding continents. The recognition of the import role of the ocean currents in forming the climate has determined regional improvements of the climatic regime since the end of the last century by changing the direction of the warm and cold currents. At the same time, we have devised to regulate and transfer the river runoff. They had big plans. Now, I think that change of winter-summer flow, 26 Niagara Falls just on those two rivers, that's a big change, a turn of the tap. And it's not, no one's talking about it. Our Arctic sea ice minimum area, boy, it's going down, especially since those 3 decades where the dam building went crazy. Kind of like Noy predicted. So what's going on in the Arctic? Now, these are new articles, and climate's controlled by how much solar energy is absorbed by the Earth and lost to outer space. There's a growing Earth energy imbalance called EEI. Now, in this article by Norman Loeb, they're about the market increase in Earth's heating rate. This quote, that EEI is due to decreased reflection of energy back into space by clouds and sea ice, and increases in well-mixed greenhouse gases and water vapor. So that imbalance is caused by that. Patrick Lynch is quoted in this article that says, Arctic is absorbing more sunlight. Since the year 2000, the rate at which the Arctic absorbs solar radiation in June, July, and August has increased by 5%, said Norman Loeb, principal investigator and a climate scientist at NASA's Langley Research Center. While a 5% increase might not seem like much, consider that the global rate has remained essentially flat during the same time. Well, that's eyebrow raising. Okay, no other region on Earth shows a trend of change. The key factors mentioned in this report are more clouds, loss of albedo, more water vapor. I can't help thinking about that humidity word in that article that all those Russians noticed. Anyway, so let's go to more of this. Now in Washington Post article, the Earth is trapping an impressive amount of heat, NASA says. There's quote, that imbalance roughly doubled between 2005 and 2019, the study found. It's a massive amount of energy, said Gregory Johnson, an oceanographer for NOAA's for Pacific Marine Laboratory and co-author of the study. Johnson said the energy increase is equivalent to 4 detonations per second of the atomic bomb dropped on Hiroshima, or every person on Earth using 20 electric tea kettles at once. It's such a hard number to get your mind around. Well, that's all from the, they're saying the sea ice melting. Well, of course, the snow cover on the land is less. But that's scary. But for discussion, did the mega dams sort of trigger the melting of the sea ice? Because now it's amplifying. Doesn't seem to be stoppable. Okay, let me go back to, got to go back to the biosphere. We've talked about the cryosphere and the atmosphere and hydrosphere. What's happening to the biosphere? It has been estimated that the present conditions, I'm sorry, this is from Noy, one of the quotes from Noy. I'm going to start with that because he gave us the first warnings. It has been estimated that under present conditions, the spring and summer runoff at the entrance to the Gulf of St. Lawrence has been reduced by between 1/3 and 1/2. This drastic alteration of the natural runoff has caused significant changes in the physics and dynamics of the waters of the estuary, Gulf, and adjacent coastal region. It is argued that such modifications produce a profound impact on the biological balance of the whole ecosystem, as well as changes in the seasonal heat budget. Also, in 1982, he said, of particular concern is the increased development of hydropower under construction or in the design stage in Labrador and Gavi Bay, James Bay, and Hudson Bay, which are bound to threaten the productivity of the Grand Banks of Newfoundland. Here's a warning. Now, pictures the Barrasso Dam. Talk about a mega dam there. Upper Churchill Falls. That's right close to the Atlantic. These are all these new mega dams. He wasn't the only one. No, he wasn't the only one preaching about this. Michael Rosengert was a fishery scientist in Russia. He had to leave about 1980 because he would have been thrown in a gulag because He was adamant that all these dams and the river regulation had destroyed the Soviet fisheries, especially in southern Russia. But he did, because that's where he did his work. The spring river runoff. Okay, here's a graph. You see it at the top. As it goes down by percentage, you'll see it affects estuarine salinity, organic matter, detention time of water, the stagnation, and the pollution times, because pollution is magnified when the runoff is decreased. And lastly, at the bottom, the fish catch drops off dramatically if the spring runoff is reduced. Now, summarizing Michael Rosengert's explanation of the impacts, he was, in summary, he said the reduction of the river spring freshet by 40 to 60%, especially in consecutive years, is devastating to the coastal fishery. Rosengert explained that when you take 60% of the natural spring flow, the lifeblood of the river ecosystem is gone. He said, it's as if you drained the blood from my body and expected me to go on living. Well, this is happening in rivers in Maine. It's definitely happening in these mega dam rivers. It's not surprising our fisheries in the ocean are hurting so badly. We'll go to one of the most important plants in the ocean. Dams and their flow regulation are adversarial to marine diatoms! Exclamation point. Diatoms are the most important foundation of the marine food chain and are one of nature's most powerful biological cooling mechanisms for global climate. How can that be? All right, well, I found this, I've seen it a few times, I had to put it in here. In Isaiah 46, it says, all flesh is grass. Well, the late Boswick Ketchum, a microbiologist at the Woods Hole Institute, revised Isaiah 46 to explain why diatoms are the gold foundation of the marine food chain. He said, all fish is diatom. If you want high quality fish, it came from the diatom food chain. Now, diatom information, important to know that diatoms need silica. They have a requirement for it. In fact, they take in 6.7 billion metric tons of silica annually. If the ocean gets low, or they don't do well. They provide 25% of the oxygen in the atmosphere. They're sensitive to timing and volume of freshwater flow. They have a high responsibility for the silica pump that sequesters carbon in the ocean depths. And this is what cools the planet. You get rid of this, the CO2 is taken in and converted to oxygen and carbon. You get rid of that carbon. It's gone. It's sequestered. Of course, I think it's known as oil now in the geologic terms, but they're responsible for about 1/4 of the primary production on the planet Earth, and of course half the carbon flux to the deep ocean. Rivers now are important because they deliver 80% of available silica to diatoms, while ocean current upwellings provide a substantial volume. But if you reduce your ocean currents, you lose that volume too. Marine diatoms dominate other phytoplankton in the nutrient-rich, well-mixed ocean surface layer. And through geologic history, they are a natural mechanism that has helped cool the climate. Silica availability controls diatom populations, which determine atmospheric CO2 levels. That's an important concept to gather here. Okay. Here's a picture of the diatoms in the Barents Sea. You can see them from outer space. Dams and flow regulation diminish diatom populations they disrupt the volume and timing of the delivering of nutrients, altering the coastal water temperature and salinity, dampening ocean upwelling current energy, and reducing the mixing of surface layers which results in increased stratification. Noy said it was like river regulations, like watering and fertilizing the winter and doing nothing in the summer and expecting your plants to grow. Well, it's kind of what's going on to the diatoms. Non-diatom phytoplankton dominate when ocean layers are stratified. Now, a NASA study says that diatom populations in a 14-year period since 1998 have been falling 1% per year. Well, that's scary. I think there needs to be a discussion about what's happening and how these megadams are a player in that decline. You look at the links, the relationships of diatoms. Diatoms feed copepods. Calanus finmarchicus is a very important copepod in the Gulf of Maine. It's important for the right whale. That's their main food. If their population, if diatom populations are diminished, copepods are diminished. In addition, the flow regulations changes the lateral movements of the copepod larvae and changes their location. Diatoms suppress harmful algal blooms, but we're getting, since according to some reports, the increased numbers and intensity of harmful algal blooms has been occurring like in the Gulf of Maine. It's been no discussion of really why, but copepods eat or consume the harmful algae and doesn't really bother them. But then the whales, right whales come along, consume them, and it can cause loss of weight and reproductive problems. So it's another impact that's happening. Now, Atlantic cod, they're of course they're going to be hurt by a loss of diatoms, and we want to talk about them because they really crashed, and you can see that in this graph. Now, there'd always been overfishing. There'd be moratoriums, and they'd come back. There was especially overfishing in the 60s, in the 70s, and then there was a moratorium, and it came back. And about right when Hans Noy warned there would be a crash when those dams, when the Hudson Bay dams came online, it crashed, and it has relatively stayed crashed along with other species. So they're, but the megadams have been left out of the cod answer. Now, I had to put this slide in because I love the picture. I bought it on eBay. It's a Hungry Horse Dam. It's in western Montana. It was built in, of course, 1953. It was finished. It was one of the bigger dams in the world when it was built. Of course, the reservoir, you see, is 34 miles long. It's on the South Fork of the Flathead River. Of course, you know that eventually ends up in Flathead Lake. It's one of the bigger lakes in North America. Now, this was from a thesis I got this from, but it quoted some very well-known and respected scientists. And it said, Hungry Horse Dam releases have thermally altered the water temperatures of the river, producing, quote, extreme ecological disturbances that have significantly reduced insect species, diversity, and biomass in comparison to unaltered river segments. Stanford and Hauer, 78. In this constant thermal regime, many species of insects presumably cannot complete their life cycles. Graham, Stanford, and Hauer. Now, before the dam, pre-1953, the unregulated river temperature varied through the seasons from 0 to 18 degrees centigrade. After completion, post-1953, the regulated river temperature remained near a consistent 7 degrees centigrade throughout the year. Now, this study was in 1960, or I think this was written in 1960, but I know they're actually doing other releases to try to solve this problem. But this kind of is kind of scary because every mega dam or a large dam or this type of flow regulation what is probably one of the biggest killers of biota on Earth if it's killing these kills the insect life. The insect life consumes the dissolved organic carbon in the water. They feed on that. You know, there's a you know, carbon what you call loss of carbon removal from the water. This should be in this more in the discussion. Now, notice the mountains in the background. That's the Rockies, and this reservoir dam is 15 miles from Glacier National Park. You remember all the humidity that was mentioned in the Russian article? Well, this dam, especially in the fall and early winter, and the river, where the river doesn't freeze, it's going to produce a lot of humidity. What impact does that have on Glacier National Park? All we see is articles about how the glaciers are about gone, and they really started kind of you know, when the dams are being built. And this dam isn't the only one that's been built in the region, so it's just another thing for discussion. It always seems to be left out. You know, this heat pollution that Noy talked about. Hope I'm not going over my time.
Yeah, you're getting a little close.
Okay, I'm about done. I sort of, yeah, their big lie. I see these clean energy corridor ads. This one says, big benefits, small footprint. It's right out of the Central Maine Power and Hydro-Quebec corporate playbook. You tell the lie as many times as you can and long enough and loud enough, people will believe it. I think it's interesting they use lobster traps. Well, lobsters are really affected by warmer water and thermal pollution, and they may want to change their picture, because what these mega dams are doing is especially, you know, it's not just Canada, because what happens in the Arctic also affects, you know, the Labrador Current. They may want to the lobstermen, fishermen may want to start paying attention to this. So small footprint. Well, I made a list of big of the impacts that we've learned along the way about the dams and flow regulation. And it's not a little list, and there's some big impacts. This is a big footprint. Some of these impacts of this big footprint that should have been included in the regulatory hearings for NECC, fishery policies, and climate change discussions. That's kind of our goal, that this starts to happen. Now, lastly, took this picture from took it from the Natural Resources Council of Maine, proposed NECC route, and there's a there's a transmission line going in. Yeah, I don't agree with small footprint here, but if the NECC line is approved in the November 2nd, 2021 referendum on question 1, this is a guarantee. More dams will be built in Canada. So that transmission line is going to equate to a lot more dams and a lot more mega damage. And I'll have this, the information for people that they can buy the book from these groups. Say No to NECA, from arcticbluedeserts.com, Friends of Merrymaking Bay, and in Canada, the Grand Riverkeeper of Labrador, Roberta, has some. So that makes mailing a lot cheaper. And for information, it's a list will be growing, I'm sure. I especially want what's happening in Canada. They're making a big, they're just assembling all kinds of information. this is being done with the help of the Grand River Keeper up there. So we want to keep you apprised of that. Okay. I guess I'm done.
Awesome. Well, thank you. Thank you, Roger. Appreciate it. Yeah, I think the only thing green about hydroelectric dams are the $100 bills that come out of the turbines, you know. So everyone knows, hopefully they'll vote yes in the November elections. And the dams really are problematic for being green. I had the good fortune as a youngster to do some paddling with the Cree up in northern Quebec, and it's like 50 years ago. And it breaks my heart to think of what's been done to that province. And the same thing would apply in parts of Manitoba and BC and throughout Arctic Russia, you know, putting relatively warm waters into the Arctic Ocean at the wrong time of year, you know.
So
So
we're running a little bit late, so I'm not sure how many questions we can fit in, but I don't see very many questions on the chat. We're losing a few people. So if we want to, if you could field any, like just a couple questions of people in the audience, if you want to raise your hand or gesture on your video to say if you've had a question, we can unmute you.
and while we're waiting, I'll put in a final plug to join us the second Wednesday of the month, October through May. We'll have more of these.
Okay, wonderful. And is there contact, Roger, for if people do have questions and they want to?
Oh, well, I left that out. Friends of Sebago at yahoo.com would be, of course, you could also contact Ed and he could give you that information too. Merry Meeting Bay. Yeah, that's my oversight.
Friends of Sebago
at yahoo.com.
at yahoo.com. Okay, I put that in the chat. I hope that shows up. And we do have several people saying thank you. That's very helpful information and more thank yous I'm seeing. So I think we're good to go. And we want to thank you very much. Ed, do you have any last comments before I close down the?
Well, just again, join us next month for the latest on Sea Shepherd, and thank you, Martha, very much for making this happen, and Roger for being our first guest with some really valuable information. And I'll also thank Tom Walling on our board, who, while we were going to have you do this presentation, Roger, Tom made the obvious point that we should do it before the November ballot.
Yeah.
Hopefully this will help people in their decision then. So thank you both.
All right, so everyone can leave, and I'm just going to end it slowly so I don't forget to do all of the jobs that I'm supposed to be doing. And
I will say, hopefully that we'll have this recording up on the website within a few days or so.
Right, and it is live streaming on YouTube now, so it is accessible. All right.
Thank you.
Bye, everyone.
Okay, thank you.